Hey WebAssembly friends, thanks for tuning in again. This video is all about continuous integration and deployment for your spin apps. We will build a GitHub action that compiles our source code down to WebAssembly and push the OCI artifact of that spin app to the GitHub Container Registry. That said, let's get started. First, let's create a new spin app. And to do so, we use the HTTP empty template. So we choose the HTTP empty template from the list of templates. Let's call our app actions-sample. Let's skip the description. Let's move into actions-sample. And as you can see, all we got is a spin.toml file, right? Next, we're gonna add an actual component. So that's spin add. And for the sake of the first iteration, we will roll with the HTTP-JS template. Let's select that one. And let's say that's the JS API. Let's skip the description. And we wanna respond to incoming HTTP calls hitting the JS route and all the routes below that one. All right, let's fire up VS Code. So we won't review the actual implementation. We will stick with whatever we got from the templates, but we will roll our own GitHub Actions workflow. So let's create a folder GitHub and a subfolder called workflows. And within that, we want to use a ci.yaml file. Let's collapse the file explorer over here and let's get started with, the bare minimum for a GitHub action. So obviously we have to specify a name. This is CI, and we have to specify the trigger on which we want to, tell GitHub that it should invoke our GitHub action, which is, for the sake of demonstration, just push. We can define environment variables, and we will do so. So we want to specify how the OCI reference of our app should be called, and let's do that by saying app name equals sample-spin-app. Next, every GitHub action must consist at least of one job. So we have to specify the jobs array and we come up with a dedicated job. We call that one again CI, which should run on Ubuntu latest. And we provide a name, which is continuous integration. We have to specify permissions for our GitHub Actions token. So we want to read the contents of our repository, that is contents equals to read, and we want to publish OCI artifacts to GitHub Container Registry, which is basically packages.write. Cool. With that, we can move on and take care about the steps of our workflow. So steps is an array of actions that are executed in the defined order. And first, we want to use the actions checkout in version 3 to get all the source code from our Git repository. GitHub Action runners have many software packages already installed on it. However, Spin is not installed by default. And to smoothen the developer experience, we published several actions that you can use as part of your GitHub Actions workflow. And we'll start by using fermion/actions for Spin, and we want to install Spin itself. That's done by using the setup action. Upon installation, we want to install plugins. So we want to install the JS to WASM plugin, which allows us to compile our JavaScript code down to WebAssembly. This is great, and we will take a look at plugins in further detail in a couple of minutes, but let's move on for now. So before continuing with building and publishing the spin app as an OCI artifact, let me quickly show how the OCI reference of an artifact may look like when you use GitHub Container Registry. So that's ghcr.io / followed by the owner. So that's your personal GitHub account or your organizational account. So let's place a token over here. Let's say owner, followed by a / and let's say app name. We have a variable already in place for that one, right? So we will use that for the app name. And obviously we have to specify some tags. So tags. In my case, this would result in ghcr.io / Thorsten Hans / sample spin app, and then we will use like the run ID followed by the run attempt of our GitHub action. Unfortunately, I decided, like, I don't know how many years ago, to go with, Pascal casing my username. GitHub Container Registry, however, wants to have the owner reference using lower casing. And to do that, we can use a simple bash command to transform the repository owner name to a lowercase string and make that available for the rest of the workflow. So we do an echo over here and specify, let's call that artifact owner, and we want to set that to the result of GitHub _repository _owner. And we can use the bash syntax to convert the value of that particular environment variable to lowercasing by suffixing the name of the environment variable with @l. And we want to pipe that result into $GitHub_env. Let's explain what that actually does by specifying a name, create lowercase artifact owner. All right. Next step is again using one of our actions, which is Fermion actions spin push, also in version 1. Let's start with the name because this one build and push the spin app. Okay, we have to specify several variables. So in order to, building is obvious, right? We must have tooling installed for the language we're using, and luckily Node.js is already installed. However, for pushing the OCI artifact to a registry, we must provide enough information for the spin CLI under the covers to authenticate against that container registry and to instruct it which spin manifest it should use and how the OCI reference should be called. So first, let's start by providing registry related information. So we want to use ghcr.io as a registry. We want to provide the username, which is github.actor over here. We have to provide a password or a token, and we can grab that one from secrets and use the GitHub token. The last bit of information for registry is how we want the OCI artifact to be called. Reference. So this one is ghcr.io / and then we will bring in the environment variables we created before. So first we take the artifact owner followed by a / and then env.appName followed by a colon, and now we specify the tag of our OCI artifact, which is us reusing variables populated by the GitHub action at runtime. So we use the run, the run ID down there, followed by a dash and another variable, which is GitHub run attempt, which is a integer value that gets incremented for every time we rerun the same action instance. Cool. That's that. There's one last property missing, which is a pointer to our application manifest. So that's manifest_file, and bringing back the file chooser over here, you can see the spin toml is in the root directory of our repository, meaning it's as simple as specifying spin.toml. All right. That's it. That should be a super simple, minimalistic GitHub action that pulls the source code. So let's add more meaningful names over here. Check out code. This one will install spin CLI, the spin CLI. Then we will create a lowercase OCI owner, artifact owner, that's right. And we will build and push the spin app. Great. In order to try that, we have to create a new repository and push our code there. Let's do that. Let's start the browser and let's go to repo.new. And let's say that's our sample or actions-sample. Let's call it that way. Let me increase the font size a little bit. All right. Creating the repo, that's a public repo right now. We copy those instructions to add the remote to our Git repository. And instead of going to VS Code, let's go to the terminal. Let's clean this one up and let's do git init. Let's do git add dot. So this will add all the files and respecting the git ignore that has been created by us using spin new. So let's do a git add everything. Let's commit it, commit-sn for init repository. Okay, and now let's bring in the commands that we copied from GitHub UI, which basically sets the origin to our new GitHub repository, sets the branch to main, and it pushes our local main branch to the remote main. Okay, cool. Let's move back to the browser and scroll to the top. Right now we can do a GA to go to the actions, and as you can see, the action is already running. So let's check what it's doing. Yeah, it's invoking our continuous integration job. It installs spin, and as you can see, JS2wasm 0.6.1 is also installed as part of that, so that's great. We create that lowercase representation of my GitHub handle, and we are already building and pushing the spin app. Successfully logged in as Thorsten Hans to registry ghcr.io and pushed with the digest, and we see, the SHA of our OCI artifact. Finally, we should get a green check mark indicating that our action ran successfully to completion, which leads us to the packages being listed on the scope of our repository. So here we can see that right now we have ghcr.io Thorsten Hans /sample-spin-app. That's the identifier of the run, and the run succeeded and pushed that artifact on the first attempt. So that's why we end up with a -1 over here. By the way, you can also browse your packages or your artifacts by going to your GitHub username and moving to packages, and there you see the sample spin app, which has been published 1 minute ago and points to the following repository. Let's do one additional step right now. Let's go back to the terminal, and what we want to do now is add another component to our spin app, but instead of using Node.js, which is pre-installed on the GitHub runner, let's add a Rust component. So let's say spin add over here, and let's choose HTTP Rust as a template. Let's call it Rusty API. Let's skip the description, and this one should invoke the component for requests hitting Rusty API, and everything below that. All right, let's move back to VS Code because we have to do some changes to our GitHub Actions workflow. Although Rust is installed on the GitHub Actions runner, the target for WebAssembly, so wasm32 WASI, isn't installed at all. And we have to do that. So there are actions available created by the community, but adding the wasm32 WASI target is as easy as executing rust up target at wasm32-WASI and provide a name. Add the wasm32 WASI target to the Rust installation. Okay, with that, we should be able to build the spin app that now consists of multiple components written in different languages. On top of that, let me commit this thing. Git. On top of that, we want to list all installed plugins because you may want to use capabilities of the Spin CLI that are provided by plugins. So it's a good, practice to inspect which plugins you get by default. And as you can see, we installed JS to WASM. So let's see what we end up with. So we do a simple spin plugins list -- installed over here. So if you take that command and execute that on my local machine, you can see which plugins I have installed already with my Spin CLI. But how will that look like in CI/CD? We will see in a second. Let me just add a name for that one. List installed Spin plugins. And commit this thing. And push everything to the remote. Let's move back to the browser. Let's do a GA to move to the actions, and let's see what we got. So continuous integration, we got a runner assigned. Yes, there we go. So first, we add the target for wasm32-WASI to our Rust installation. That succeeded. We install the Spin CLI. That's also succeeded. And as you can see over here, the only plugins that are installed on a GitHub Actions runner are those that you explicitly mention as part of the plugins property when using the setup action. Great. Let's wait a second to see that app also being published to GitHub Container Registry, and we got back a green check mark. So overall action status is green again. Let's go to code. And by looking at the details of the package, we can right now see that we have two different tags of our OCI artifact published in GitHub Container Registry. If you want to check out which actions we provide on top of those that we used, you can go to github.com/fermion/actions. And there we have documentation in place for all the different actions that you can use to, automate everything in the context of your spin apps. Awesome. That's it. That's how easy it is to automate continuous integration for your spin apps. The continuous deployment part obviously depends on your target environment. So you can use things like the Cube plugin to scaffold out Kubernetes deployment manifests, and you can use existing actions provided by GitHub itself or by the community or by cloud vendors to take your spin app and deploy them to your Kubernetes environment that runs SpinCube or Fermion platform for Kubernetes. As always, I want to engage you to give us a thumbs up, to subscribe to our channel, And leave in the comments down below which great things you do within GitHub Actions. I'm curious to explore what you guys are building out there on GitHub's great CI/CD system. With that, thanks for tuning in and see you next time.